So before we start talking really about polynomials, which means many monomials, I want you to know what is a monomial. So good, yes. The prefix mono means one. So we're just talking about one of these. And it can be a variable, a number, a real number, or it can be a combination of those. And I'll give some examples of monomials. For instance, we could just have u. We could just have -5. We could have 6u to the second power. We could have 8u to the third power v. All of those are examples of monomials. And we've seen these before when we have looked at expressions and we combined like terms, or even when we were solving equations and we had to combine like terms. Okay? And we'll be doing that again today. So polynomials would be having two or more of these monomials added together. Okay? So again, a polynomial two or more monomials added together. Two or more monomials added together. For example, 3x to the second power minus 5x plus 2. And we've seen expressions like this before. So you may be thinking added, but there's a subtraction sign here. Remember that you could say 3x to the second power plus -5x plus 2. Okay? So this is just a more simplified version. We've talked before about when we were combining like terms, about how many terms there are. Now, we didn't call them monomials, but there are terms. So how many terms are in this expression here? 3 terms. We have this term, we have this term, we have this term. So 3 terms. And we need to remember when we're looking at these terms that the sign in front of it, whether a positive sign or a negative sign, a plus sign or a minus sign, that the sign in front of it goes with it. The sign in front goes with it. So that was really important when we were combining like terms, to know that the sign in front of the term goes along with it. Now that we know that this is called a polynomial and that each one of these terms is called a monomial, since we have 3 of them, what type of polynomial do you think it is? Okay, good thinking. So you know that a polygon has more than 3 sides, really, right? And a triangle is a type of polygon. So tri, the prefix tri means 3. So this technically, instead of saying a polynomial, we could call it a trinomial. Okay, so 3 terms would be a trinomial. It is fine to call it a polynomial, just like calling a triangle a polygon is fine. But if you want to be more specific, then it is a trinomial. Yes? Yes. Technically, though, they just use monomial, binomial, trinomial, or then just polynomial. Okay? So again, monomial is 1. Monomial is 1 term. A binomial, like a bicycle, binomial is 2 terms. Trinomial is 3 terms, and then you would just use polynomial for more than that, okay? So all those prefixes that you've learned about in language class kind of help you out with this. Okay, now we're going to talk about the different degrees of a polynomial. But before we talk about the degree of a polynomial, I want to talk about the degree of a monomial. All right? I still see a couple people writing, so I'm going to pause for a second. All right, so again, we're going to talk next about the degree of a monomial. To find the degree of a monomial, we are going to add together any exponents that are on variables, okay? The sum, so adding, of the exponents with variable bases. So again, we're only looking at the exponents that have a base that is an exponent, for instance. And again, we're just talking about monomials right now. If we had 7x to the second power y, this is a monomial. You don't see any plus or minus sign, so it's just one term. In this one term, we have a 7, we have an x to the second power, and we have a y. What is the exponent on that y? A 1, okay? So to find the degree of this monomial, we are only looking at the 2, because it has a variable for a base, and this invisible 1, because again, it has a variable for the base. We do not think about this 7 as having an exponent. Now, it technically does. The exponent has an exponent of 1, but again, we're only looking at the exponents that are on variables. So to find the degree of this monomial, we are going to add up these 2 exponents. So 2 plus 1. So this monomial has a degree of 3. Again, this monomial has a degree of 3. So you're adding up the exponents that are on variables only. So let's look at another example of that. Let's say we have the monomial 16 a to the third power, b to the second power, c. What would be the degree of this monomial? Jacob? 6. Because we have a 3 plus 2 plus this 1 that is invisible. So 3 plus 2 plus 1 is 6. So the degree is 6. Okay? Does that make sense? All right. When we're talking about finding the degree of a polynomial, what we're going to do is we're going to look at each monomial, okay, each term individually, and we're going to find the degree of each term, each monomial, and then whichever term has the highest degree, then that's the degree we're going to use for the entire polynomial, okay? So use highest degree of monomial. I'm going to do a trinomial up here. We'll give you 3 terms. So the degree of the polynomial, we're going to use the highest degree of its monomial. Whichever monomial has the highest degree is going to be the degree of the entire monomial, or the entire polynomial. So again, this polynomial has 3 terms, so it is a trinomial. What is the degree of this first term? 4. What is the degree of this term? 3. This 2 plus the invisible 1. Remember, we don't count that number in front of any variables. And what is the degree of this last term? So the highest number here, 4, 3, or 5, is the 5. Okay? So the degree of the entire polynomial is 5. So we found the degree of each monomial individually, and then whichever one was the highest, that's the one that we use for the entire polynomial. Make sense? Okay. Then, lastly, let's talk about simplifying polynomials, which I think you'll find pretty easy because we've done it already this year. We just didn't use the terminology necessarily. So, when we simplify a polynomial, it's called standard form. And when we write standard form, we want to basically do 2 things. We want to combine like terms. Do you remember when we talked about like terms earlier in this school year? What we said, like what makes them like terms? What symbol? The variable. So it's super important that when we're looking for like terms, that they have the exact same variable parts. Not just both of them having an x, but the x has to have the same exponents as well. Okay? So, same variables, and I'm going to put variables slash exponents. So again, we're going to combine like terms. And the other part of this is that we are going to, in our final answer, we're going to order the terms, or monomials, by degree. We want the greatest degree listed first to the smallest degree. So order degrees from greatest to least. Okay, so we'll spend some time just practicing that. And then we'll be finished with notes today. I'm going to write a polynomial up here that is not in standard form, and we're going to put it in standard form. So 7w to the third power plus 2 plus w to the third power plus 5w to the second power minus 5. Now, I don't know about you all, but I kind of like to do 2 steps at once because it makes it easier for me. So if you look in the textbook, the first thing that it would do is it would reorder this. It would use the commutative property to reorder your terms so that you had your like terms by each other. And then it would simplify, it would combine like terms, and then it would make sure that your terms were in order. But what I like to do is I like to look through here, And I like to think to myself, all right, I see that there are how many terms here? 5 terms. There's 5 terms, okay? And I like to think, all right, of these 5 terms, which one of them has the highest degree? Okay, the coefficients, the numbers in front of variables, do not have anything to do with the degree. Remember, the degree is the sum of the exponents on a variable. All right, so let's think about this then. So this has a degree of 3. This one right here, we didn't talk about when you just had a number with no variable. So if what I'm saying about the degrees, if it's the sum of an exponent on a variable, if there's no variable, then the degree of this term is 0. I'm going to put over here degrees so we know what these numbers represent. What about this w to the 3rd power? 3. What about 5w squared? 2. And a negative 5? 0. Okay? So now when I ask which of these terms has the highest degree, it would be w to the 3rd power. Now we have 2 of those, don't we? We have this one and we have this one. They both, oh, sorry, wrong one, this one. Both of those terms have a w to the 3rd power, meaning those are like terms, okay? There is another term that has a w, but it's not a w to the 3rd power. So you can only combine w to the 3rd with w to the 3rd, okay? So if I combine this term with this term, what do I get? 7 plus 1, right? 7. This is a positive w to the 3rd power. So technically out in front of here is a 1. So 7 plus 1 is going to give me 8 w to the 3rd power. Questions about how I got that or why I did that first? Okay, and again, I want greatest to least. So that was my greatest degree. What is the next one then? 5w to the 2nd power. Can I combine anything with that? No. There's nothing that can combine with this one. Nothing else has a w2. So it's just going to be plus 5w squared. And then lastly, I have 2 numbers that do not have variables. Those are called constants when they don't have a variable. And I can combine these things. So I can combine this positive 2 with this. Remember, the sign in front of it goes with it. A negative 5. So a positive 2 and a negative 5 give me negative 3. And you're finished. So to review what we did to simplify this, I first looked at how many degrees is each term by itself. Then I worked with my terms that had the highest degree, and they were like terms because they both had w to the 3rd power. So I did 7 plus this invisible 1 coefficient to get 8 w to the 3rd power. Then my next term is 5w squared. There's nothing I can combine with that. And then my last terms have a 0 degree, positive 2, and a negative 5 give me a negative 3. All right, want to try one on your own? Well, we aren't done yet. We have other, it gets harder. Sorry. Turn the paper over. Not that big. Alright, how many terms does this polynomial have? 4 terms. What is the highest degree we have? 4. 4 is the highest degree. So looking at the term or terms that have the highest degree, This has a 4, y to the 4th, and this term has a degree of 4. And they both have the exact same variable part. They both have a y to the 4th power. So I can combine those two terms and get 12y to the 4th. Then I look at my two other terms, which obviously, hopefully is obvious, are not like terms. One of them has an xy squared and the other one does not. Which one of those terms should I list next? Good. I want to list this next because how many degrees is that? 3 degrees. Excellent. And then lastly will be this 5 by itself. Okay? Where are we at that? Alright, to add a little bit of complexity to it, we have been distributing for many months now. So you will have the distributive property as part of your simplifying process. Let's try that. So when I glance at this problem, this expression, I see parentheses. Parentheses always mean do that first. We can't add what's inside of the parentheses, but that is going to give us a reminder that we need to distribute. What number do we distribute? The 2. So is it a positive 2 or a negative 2? Positive 2, so that plus sign in front of it lets us know it's a positive 2. So what is positive 2 times a positive 4m? 8m. And what is positive 2 times m squared? A positive 2m squared. Good. Okay, so a positive 8m and a positive 2m squared. Now we did not do anything else with the front of this expression, so I am just going to rewrite my negative m squared plus 5. Okay, so that took care of distributive property. Now we're thinking about the degree of each monomial. What is the highest degree we have? 2. And the terms that have a degree of 2 have the exact same variable and the exact same exponent. So that means I get to combine them. This is a negative. A negative what number? A negative 1. Okay, a negative 1 plus 2 gives me 1m squared. And even better if you knew just to write m squared. So this is acceptable to write 1m squared, but yes, it is much preferred if you just write it as m squared, knowing that it means 1m squared. Alright, and then what's next? 8m, and then 5. And you're done. So this, technically, even though it started off as more than 3 terms, is now 3 terms, or 3 monomials, so it would be called a trinomial, and it would have a degree of 2, because that is the highest degree. Okay? The only other thing that I'd like to review, we don't necessarily have to do a problem in your notes, but how do you find perimeter of a shape? Add up all the sides. So you're going to have 2 problems on your assignment that ask you to find the perimeter, or write an expression to find the perimeter. So you're just, the sides will be monomials, you're just adding them together and simplifying. Does that make sense? Or do you want to do an example? I didn't figure you did. Okay, I'm going to give you your worksheet. You have the rest of the time to work on it then.